Hi, my name's Rhonda Millikin, and I'm honored to be presenting on behalf of Claude Mindorf, Director of Development for PACE Canada LP. Our topic is sustainability. Okay, so PACE has interest in 1.9 gigawatts of solar and wind projects. Some are underway, some are not yet permitted. I'm going to talk to Caroline and Brooks later in the slides. Short reminder that sustainability has three dimensions to it, environmental, social, and economic, and they're nested such that economy base is dependent on society and both are dependent on the environment. So my focus with PACE is ecosystem sustainability, combining technology and direct observation so we can ask why an impact may occur. All innovation must first address the concerns of the community, both government and farmers, with respect to solar. And this slide shows PACE's approach. First, the concern of loss of agriculture is addressed by increasing crop productivity and land utilization. The concern of loss of wildlife habitat is addressed by elevated panels to provide solar energy and wildlife corridors. Mitigating climate change is addressed by moderating extremes to the plants, shade, providing shade and rainwater collection, plus research on increased crop resilience. The concerns of food security are addressed by researching potential for diversity of high-value crops and high nutrition. Concern for community well-being is addressed by providing visual buffers to the panels and better working conditions. And finally, concern for agriculture economics by generating non-traditional farm revenue. So solutions need to go beyond what is required to what we can do better, particularly with the brittle growing conditions with climate change. We need to go beyond what AUC requires for soil measurements. Healthy soil is what we need for healthy crops, and what PACE is doing is collecting these additional parameters. We're also collaborating with Agrivoltaics, thanks to Joshua, wherever he is, we have a funding proposal with Agriculture and Agri-Food for a mobile soil lab in collaboration with Medicine Hat College to build the next generation of soil scientists to be local and to be trained in methods needed for ecosystem sustainability. So this is the farm plan approach that PACE is taking to incorporate Agrivoltaics farm plan. And just some of the some of the aspects are targeting outcomes for government and stakeholders with the 30% renewable energy, for example, in Alberta, starting with a GIS planning layer to incorporate pre-development suitability by working with the lower value agriculture. We can maximize our win, providing better productivity, and with the results that are associated with the GIS layer, locate challenges in space and time to help explain why. In each of the projects, use a BACI design, so before, after, in a controlled situation with high replication. For our site metrics to include land use efficiency, and health metrics to include soil biology, not just chemistry, diversity, and carbon sequestration, and monitor for efficacy. The plan for 2024 is to measure the growth of 3 to 4 crops over 4 farms, to include crops that we need to know more about and crops that are horticulture-based that we'll need to know about in the future. So this is the Caroline project. It's type 3 land. The question we have here is how to make a grazing system. They're using sheep and they also have honeybees, how to make a grazing system more effective. With Brooks, this is a quarter section with salinity issues. The opportunity here is to look at habitat connectivity for wildlife, extending the stand of trees to a hedgerow to provide habitat for raptor predators and bat foraging, and to incorporate the native grassland that's present as a potential for self-seeding. We have a habitat stewardship program proposal in place to augment habitat for native grasses, pollinator plants, and perennial shrubs. And in case this seems not doable, this is a project I've been working on for the last 3 years in vineyards in British Columbia, where I'm working at increasing the predator-prey systems. So it's an ecosystem sustainability approach, looking at predator-prey systems below soil and above soil, bringing back native plants within agriculture, and using extracts from the compost to augment the soil biology. Everything's applied with an electric vehicle, which you can see in the bottom right, to soil and foliar. And the results we've had so far after 2 growing seasons is 96% of the native plants are spreading, which is helping to control weeds. That's 27 different native plant species. I've increased the species at risk bat foraging within the vineyard. They provide a pest management service and poop nutrients back into the vineyard without the requirement for fertilizers. And I'm increasing climate change resilience which is monitored by increase in organic matter, increased water retention, diversity, and control for frost damage. And the flavor profile has also been increased based on chemistry analysis and sommelier panel. And up at the top right, you can see, which I think is important for all agricultural applications, soil biology influences what we perceive as a flavor profile. And that diagram there shows different fingerprints, if we will, of soil biology that's influencing the flavor of Chardonnay wine in California. So I'll leave it at there.